class water. I can feel it. This is the one. It's working. This is it. Yes. Yes. This video has been sponsored by Pronamel. Here at Kingwell University's Department of Illusions, we've been studying the physical properties of the dihydrogen monoxide compound. Don't let that scare you. Dihydrogen monoxide is H2O, colloquially known as water. And we've been studying its illusory potentialities. In this video, we aim to document our more successful research. Now, Dr. Irving is in charge of our hydrophobic solutions. Hello, Dr. Irving.
Hello, Dr. Kingwell.
Now, what exactly is a hydrophobic image?
Well, I have these two boards here to demonstrate. Now, this one is the regular one. Look how it darkens when wet. However, this one over here is entirely different. See how the water stays together? That is because the hydrophobic solution has been applied to the outside, and so the water simply glides across the surface.
It's a curious behavior indeed.
I have something I think you'll like very much, Dr. Kingwell, please. Take that hose and spray it on the ground right here.
Well, I'll be. It's the school logo, but on a gigantic scale. How truly magical, Dr. Irving. Thank you.
Thank you, Dr. Kingwell.
Now, here are a few illusions you could try at home. If one decides to peer through a glass of water, they'll find their world very distorted. And this is due to an effect called refraction, which is where light rays hit the glass of water, bend, and travel through, changing our original perception of that object. Now, to demonstrate, I have a pencil and a glass of water. And you'll notice how through the water, the pencil looks bent. This is due to the bending of light. However, if I pull the pencil out, it's... Charlie, have you been changing our lab equipment out? From the side view here, the spoon appears to be split in half, but obviously that's not the case. When I pull it out of the What in Sam Hills is going on here? Dr. Irving. Refraction is now making this candy look bigger. However, if... Folks, one moment. We have a few things to iron out. Sorry about that, folks. Never a dull moment in the R&D department. I'm here with Dr. Bond, who's come up with a new effect using refractions.
Right you are, Dr. Kingwell. So here we have a container that looks, by all accounts, ordinary. However, all this time we've been hiding a whole person.
Dr. Irving, hello.
Hello there.
That's remarkable, Dr. Bond. Now, how is this achieved?
Oh, so if we take a look at this back container here, you see that there is an empty part of the wall that you can see, and this front container takes that part and isolates it, effectively rendering Dr. Irving invisible. But clearly, he is right over there.
Dr. Irving, give me credit. Let's cut.
That's a cut.
Apologies, Dr. Kingwell. Can we cue the commercial? 9 days. It was 9 good days. So what do you say, Sally? How about you and me go steady, huh?
Oh, I don't know, Jim. I'm not sure it'll last.
What? Us?
No, your enamel.
Chin up. Got just the thing for you. Pronamel Mineral Boost works with your mouth to replenish vital minerals into your enamel to help keep your teeth strong, white, and healthy. Really?
I'm sorry, I left my purse.
Jim, do you vow to use Pronamel Mineral Boost twice daily to protect your enamel from acidic food and drink?
Boy, do I!
You can find Pronamel Mineral Boost anywhere you buy toothpaste.
Welcome back to the program. In front of me are 3 glasses of water, but one is not like the other. Can you guess which one? Stop that one. It's not that one either. Ah. Did you guess it right? Submit your results in the video commentary below. Now, the reason this object appears to be floating in water is because of these cubes. But, in fact, when you drop them in water, effectively become invisible. Now, this container is filled with polymer spheres, and without water, you cannot see what's inside. But once you pour a glass of water, and what's inside is our reminder to please push the approval button if you're enjoying the program. And hit the bell to ring to be notified of our most up-to-date illusion research. Now next, I believe we have a more colorful illusion in store. This is Dr. Rivers, and she's discovered something fascinating happens when you add color and water.
Yes, Dr. Kingwell. We'll be using these water-filled containers to demonstrate. Would you be so kind as to switch to the first picture?
Certainly.
Observe what happens when I put this red dye into the water.
The sun completely vanishes.
Yes, Dr. Kingwell. Colored water is magical. Of course, the sun is still there. Could you switch to the next image, please?
Certainly.
Now, the red water has the opposite effect, making something more apparent.
Et illusio magica, the school motto. That's fascinating.
I wonder, though, do you see the secret word?
I can't say I do.
Could you please? Dr. Kingwell, this is a word you'll want to remember. Rain.
Thank you, Dr. Rivers. Sounds like where we're going, we may need an umbrella. It appears we need a passcode to get in. Rain. R7, 2 for A, I is 4, and 6. Now we can enter the secret lab. This is a peculiar machine, one that uses strobe lights and time mechanisms to make it appear that the drops of water are traveling upwards, when in reality, they are still falling. And that made us wonder, what if we could defy the laws of gravity and make rain go not down, but up instead? What would that look like? First, I must change my attire to show you. Isn't that just fascinating? Although the umbrella isn't doing much good. While anti-gravity rain is impossible for now, isn't the visualization of it just amazing?